Welcome to our first lesson. We are going to look at numbers as specified in strand 1 of the syllables, and it has to deal with the first sub-strand, this with counting, representation and cardinality. So how to count the numbers, to represent the numbers, and the cardinality here means their position. That's when we are arranging the numbers. Our lesson 1 goes to this. Let's look at the counting system in the beast. 10. Obviously, how many pots do we have in the box here? You realize that what we have there is a 1. The 1 that we are going to write, how many groups of 10 can we get out of this? Obviously 0 groups of 10. And what is the remainder? It's 1. So we say that 1. We don't actually bring 0 before the number. It is insignificant. Then, how many groups of 10 can we get out of this? We can get 0 groups of 10. And what is the remainder? 2. How many groups of 10 can we get out of these 2? 0. What is the remainder? 3. Again, how many groups of 10 can we get from this? 0. And what is the remainder? 4. Next, how many groups of 10 can we get out of this? 0. 0 groups of 10. What is the remainder? It's 5. We proceed like that and realize that this 1, 2 will give us 0, 6. The same way, 0 groups of 10, 1. The remainder is 6. Excuse me. 0 groups of 10, and the remainder is 7. Here we are going to have 0 groups of 10 and the remainder is 8. Here we are going to have 0 groups of 10 and the remainder is 9. Please take very good note of this. We are starting our mathematics lesson as if you don't know anything about mathematics. All what you know is you are able to identify the symbols, the numerals 0 to 9. So we are explaining the meaning of the numbers that we've been seeing in our everyday life. Okay, let's move on. The trend is changing. Alright. How many groups of 10 can we get out of this? We have 1 group of 10. Good. And what is the remainder? If you were to take 10 out of this, 10 spoons out of this, how many spoons are going to be left? That is the remainder. And we are going to have 0. We then say 1, 0. That is 10. 1, 0. 1 group of 10, remaining 0. Alright. Here, when we take 10 away, what is the remainder? 1. So we have 1 group of 10 and the remainder is 1. Here, we have how many groups of 10? 1 and the remainder is 2. So we move on like that to get 13, 14, 15, 16, 17, 18. So 1 group of 10, remainder is 7. One group of 10 remainder is 8. One group of 10 remainder is 9. 19. Let's see. How many groups of 10 can we get here? 2. 2 groups of 10. After we've taken these 2 groups of 10 away, or if we grouped them, after these 2 groups of 10, what is the remainder? 0. So we have 20. In the same way, we have 3 groups of 10, remainder 0. 4 groups of 10, remainder 0. In that order. That order. So here we have 8 groups of 10 remaining 0. 9 groups of 10 remaining 0. Excuse me. Remaining 0. Alright. We are moving on. Okay. Take your time and count this. Each column and row contains 10 each. Okay, so how many do we have? How many groups of 10 do you get? You get 10. 10 groups of 10. What is the remainder? The remainder is 0. We now say we have 100. This is a number modeling, or what we see every day in mathematics, the numbers. You realize that all numbers are being written using the symbols 0 to 9. And these are their meaning. So we have 100. Alright. For space, to simplify things, we are now going to use colors to represent the groups of numbers that we've been talking about. So when you see green, let that one represent 100. When you see one green, it represents 100. You see the orange one, it represents 10, and the blue one represents 1. So let's see how many groups of 100 do we have in this box. We have 100. How many groups of 10 do we have? We have 2. How many groups of 1 do we have? We have only 1. So what number do we have here? Alright, let's see. You realize that 100, you have 1 of 100. Only 1 of 100. The 10, how many do you have? Alright, you have 2 of the 10. Then 1, how many of it do you have? You have only 1. Okay, then this is the number that we have there. 1 to 1. Here we are only interested in writing them in figures, not in words, using the symbols 0 to 9 to write numbers. When we talk of a number, the name and what it represents is the number, but the symbols we call numerals. So we are using the numerals 0 to 9, and that is the only numerals that we have. These are the numbers. Let's move on and see. So we see 121. 121. Whenever you see a number, the last 2 digits is mentioned as though there is no any other thing attached to it. So you realize that the 21 at the last we see 21. At the beginning of it, suppose it's not there, it were to be 0, 0. How will you call it? You will say 100. If 0 were to be at the place of 2, 0 were to be at the place of 1, you will say what? 1, 0, 0. That one is 100. But now this one is, so we say 121. Alright. We shall talk more about that later. Let's see. How many 100s do we have here? Or how many hundreds do we have here? Let's count and see. We have 5 of them. I think we also had the same thing. Alright. We have 5 hundreds. The hundreds are 5. So here, the name you are going to have is going to be 500. Okay. And something. How many 10s do we have? 0. We don't have 10 there. It's 0. And how many ones do we have? We have 1. So we see 501. Remember that at one point that we had 01, we said that it's not significant. So it's the same thing here. When 0 precedes a number, it's like there is nothing there. And truly, there is nothing there. Nothing here means there is no 10 there. So we see 501. That is how to write figures. Modeling them is what we are talking about here. We could not use these small squares. 500, even you cannot count them on the screen. So we are modeling them. We are using a system to represent the numbers to make things quite simple. Okay. Let's look at the next. How many 100s do we have here? I do say how many 100s because one of the green represents 100. Okay, let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright. Then, how many 100s we have there? We have 900s. 9. How many 10s? 0. How many 1s? 0. So we have no problem. We simply say 900. There is nothing there, so we are not going to see any other thing in addition to it. 900. Alright, so we have 900. If there were to be only one of the green, we will see 100. Alright. Let's see. How many of the greens hundreds do we, how many of the hundreds do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright. So how many hundreds do we have here? We have 10 hundreds. 10 hundreds. The hundreds we have there are 10. So we have 10 hundreds. Alright. 10 hundreds. Okay. How many 10s do we have there? 0. How many 1s do we have there? 0. So the American will say 1000. But we are in the British system. We see 1000. We no longer see 1000. Hundreds are gone. When we are counting, the moment the number of digits, when I say digits, the symbols representing a number, when they turn into 4, it means we've moved from the 100 group to thousands. So we now see 1000. We now see 1000. That's a 10 hundreds. 10 hundred. We see 1000. We have brought another digits. Now you realize that we have 4 digits now. So we've brought another thing, the purple color. Whenever you see a single table, it represents 1000. So let's move on like this. How many thousands do we have here? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright. So we have 9 of them. How many hundreds do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9. So we know that we have 9,000. And how many hundreds? 900. So we have 900. 9,900. We have 9 of the thousands here, and we have 9 of the hundreds here, 900. Alright. How many tens do we have? We have 2. And 2 tens. When you have 2 tens, 2. How do we call it? We call it 20. We know, we call it 20. So we have 900, 10, and 20. We have 20 here. 20. How many ones do we have? 1. So, and 21. And 21. And 21. The last 2 digits of a number is represented. We mention it, or we mention it in the way it was done when it is alone. So we say 9,921. Alright. Let's see this one. We have how many thousands here? Excuse me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so how many thousands do we have here? We have 10 of the thousands. How many hundreds? 0. How many tens? 0. How many ones? 0. So we now say 10,000. We see 10,000. Nothing else. 10,000. So we are moving on. Our symbols. We've now moved to 5 days, so we are going to introduce another one to represent the thousands. 1,000. So let's see. When you see this light blue here, it represents the light blue here. You see represents 1,000, 10,000. Excuse me. Okay, how many 10,000s do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 of them there. How many 10,000? We have 10. Alright. How many thousands do we have there? How many 1,000s do we have there? No 1,000. How many 100s do we have? No 100s. How many tens do we have there? No tens. So we have 0. How many ones do we have here? We have 0. So you realize that now we have 100,000. Whenever the digits of a number is more than 4, group them into 3 from right to left. Group them into 3 from right to left. So we have our first 3. Our first 3 zeros fall into one group. Any digit there, just group them like this until what you get at the left, what is remaining at the left, is not up to 3. Then you leave it. Okay. So if you group them into 3 now, in groups of 3, we have one group. The rest is not up to 3. The rest too is 3, and that is all. There is no other digit there. So what we do next is, the moment the entire thing is 5 digits like this, we start saying 1,000. We know that the digit left at the right side is 3, so it's in 1,000. Then what is left at the left? The remaining ones at the left, if they are standing alone, how do we call it? We will call this one 100. Okay. So you see 100,000. So this one is 100,000. All the digits are 0. So 100,000. As simple as that, as we did for the 10,000. Excuse me. has some code. So we have 100,000. So remember that we are going to introduce another color again. In the future. But all what we've learned now, we know that we have learned the numbers in some groups where we have 1, we have 10, we have hundreds, we have 1,000, we have 10,000, and 100,000. We want to end our lesson here. In the exercises that follow, you are expected to complete them all. You want to test your understanding, how you understand the system to this point, then we proceed. Thank you for your attention. We shall continue.